Okay, let's unpack this. We're diving deep today into, well, one of the more chaotic moments in recent cloud history, the major AWS ACIS 1 outage. And this really wasn't just, a few servers blinking off.
No, not at all.
The analysis we've pulled together describes it as more of a systemic shockwave. It exposed a vulnerability that almost no one really knew existed deep
It
down.
was definitely a fascinating event. Maybe terrifying, too, depending on where you stood.
Mm.
For a lot of folks, the first sign something was wrong was just sheer perplexing chaos.
Right.
You had these big names, platforms like Cloudflare, Vercel, Datadog, all suddenly sputtering or just failing at the same time.
Seemingly unrelated failure.
Exactly. And our sources confirmed, yeah, it was a cascading catastrophe. Showed a really dangerous concentration of risk that was kind of hidden in plain sight deep within the tech supply chain.
And that's really our mission today, isn't it? To decode that catastrophe. We've looked at the technical root causes, tried to understand the business fallout, and we want to distill the strategic lessons.
Absolutely critical lessons.
For tech leaders, investors, anyone building on the cloud, really. Lessons from the AWS outage deep dive analysis you shared.
Yeah, because we need to get past just what broke. We need to understand why that specific failure had such a massive, massive blast radius.
Okay, let's start right at the epicenter then. The failure originated like so many times before, it seems, in ACIS 1, Northern Virginia. Why is that region always seemingly ground zero?
Well, it's AWS's oldest region. It's their largest. It's kind of the historical core, the main hub. And when it had problems this time, it wasn't just, some compute instances.
No.
It took out three absolutely foundational services that act basically like the central nervous system for the whole cloud platform.
Okay, let's break this down. The first one, and arguably the most crippling, was Identity and Access Management, IAM. Can you just walk us through what that failure actually meant? Like for people using AWS.
Sure. So IAM is essentially the universal gatekeeper. Think of it like that. If you can't authenticate, you can't prove who you are, then you can't authorize anything. You can't get permission to do anything.
So everything else stops?
Everything stops. When IAM's core functions, the authoritative parts, failed, it just disabled what the analysis calls the authorization fabric.
Authorization fabric, okay.
Yeah. So API calls started failing everywhere, not just in ACIS 1. Login pages were timing out. It basically paralyzed huge chunks of the platform.
Wow. So even if my actual application server was running perfectly fine, say, in Ireland, it couldn't get permission to do anything useful, like talk to a database or read from storage.
That's exactly it. That's systemic failure right there. Your app is up, but it's useless.
Okay. What were the other two major failures?
The others were Amazon Kinesis, which is their service for real-time data streaming, and Amazon Cognito, which handles user identity, logins, signups for lots of mobile and web apps.
Right, Kinesis. So when that broke, what happened?
Well, all those real-time data pipelines, things like logging, analytics streams, event-driven architectures that react instantly to data,
Yeah.
they just stopped, dead in the water. And that meant immediate data loss for some systems and just a huge breakdown of critical business processes that relied on that real-time flow.
Okay. Data loss, broken processes, and Cognito.
Cognito failing meant thousands, maybe millions of end users of customer applications suddenly couldn't log in. They were just locked out of the apps they use every day.
Ouch. Yeah, that's bad. What really stood out to me looking at the timeline in the reports was how fast the broader engineering community seemed to figure this out. Faster, even, than the official AWS status page updates.
Isn't that fascinating?
Yeah.
It really is. The first solid clues that this was something big, something widespread, didn't really come from AWS initially.
Right.
It came from engineers talking on places like Hacker News, on Twitter. They were comparing notes like, hey, my logins are failing, my API calls are breaking, across totally different services.
Like the Vercel, Cloudflare.
Exactly. The community effectively crowdsourced the diagnosis. They put the pieces together really quickly and realized, okay, this isn't just me. This isn't just Vercel. This points back to something fundamental at AWS.
Which really sets the stage for the big, the million-dollar question, I guess. How does a failure that's supposedly confined to one single region, Northern Virginia, how does that cause a global crisis? Taking out services that are running perfectly fine, technically, in London or Frankfurt or Sydney, it means we have to look at the architecture, right?
Exactly. This is where we get to the absolute core of the issue. The report calls it the illusion of global services.
The illusion of global services. Okay, because most of us, myself included probably, assume that services like IAM, marketed as global, are genuinely immune to a regional failure. You hear global, you think Redundancy, right?
That's the natural assumption.
Yeah.
But you're saying the expectation was, well, dangerously flawed in this case.
It was, yeah, dangerously incorrect is how the analysis puts it. We need to sort of peek under the hood a bit at the difference between what's called the data plane and the control plane.
Okay, data plane versus control plane.
So the data planes, these are the bits that actually do the work, like evaluating permissions once they're already set up. Those might be distributed quite well. They might keep running for a while, even if another part is broken. Okay, so the checking of permissions is maybe okay, but
But the control plane, that's the authoritative source. That's where you manage identities, change policies, update configurations. It's the brain, essentially.
and that's not global.
For IAM and some other critical quote-unquote global services, that authoritative control plane is centralized. And it's homed firmly in US East 1.
Ah, okay, this is critical then. So let me see if I understand this. If I run my main application, say, in Paris,
Yep.
but that application needs to do something like spin up a new temporary server, or maybe more commonly, it needs to get temporary security credentials using the security token service, STS.
Right, very common.
That vital request actually gets routed all the way back to Northern Virginia, even though my app and my users are thousands of miles away.
You've just nailed it. That is exactly the phantom dependency.
Phantom dependency.
Wow, this architectural choice, centralizing that control plane, creates this hidden dependency. And it's capable of just completely overriding, nullifying even really expensive, carefully designed, multi-region disaster recovery plans.
Because US East 1 becomes the single point of failure. The analysis called it the glass jaw.
The glass jaw, exactly. If US East 1 fails in the wrong way, applications all over the globe can be hobbled or stopped dead because they depend on those control plane operations that are bottlenecked right there in Virginia.
Honestly, that feels like a massive oversight for a company as sophisticated as AWS. Why would they design it that way, creating such a huge potential single point of failure?
It wasn't an accident. The analysis points to a really fundamental trade-off they made, probably years ago.
A trade-off.
Yeah. Centralizing the control plane makes things dramatically simpler for AWS's own internal engineering teams. Imagine managing identity consistency across dozens of regions simultaneously. It's hard.
Okay.
Centralization guarantees strong consistency for policies, for identities. You never have to worry about like two regions having conflicting security settings for a fraction of a second. So they prioritize their own internal development speed and that strong consistency
Over what?
over providing customers with true ironclad regional fault isolation for absolutely every aspect of every service, especially those control plane functions.
Huh. So, putting it bluntly, we, the customers, ended up inheriting the risk that AWS took on to simplify their own internal engineering challenges. That's a tough pill to swallow.
It really reframes the whole incident, doesn't it? It shifts the conversation away from just a technical glitch towards, well, an economic one.
Yeah.
Which brings us to the blast radius analysis, the second wave of the outage.
Right. This is where that concentrated risk you mentioned earlier really, really hits home, because it wasn't just people running basic EC2 instances or S3 buckets that went down.
No.
The confirmed list includes Vercel, Heroku, Cloudflare, Fly.io, Okta. I mean, it's a who's who of platform as a service, edge computing, content delivery, identity providers.
And critically, as you mentioned earlier, Datadog was severely impacted. Just think about the implications of that for a second.
Your monitoring system goes down.
The very tool you desperately need to figure out what is going on, why your systems are failing, that tool is taken out by the same underlying failure. It's instantaneous operational blindness, paralysis.
Yeah, that's terrifying. And this whole situation really exposes the illusion of diversification, doesn't it?
Absolutely, yeah.
CTOs, engineering managers, they often pride themselves, rightly so sometimes, on diversifying risk by using different vendors. I use Vercel for my front-end hosting, I use Datadog for observability, maybe Okta for identity.
Trying to avoid putting all eggs in one basket. Makes sense on the surface.
But if all those best-in-class solutions, Vercel, Datadog, Okta, whoever, if they all ultimately rely on the same single core AWS hub, like US East 1, then that diversification you thought you had, it's just an illusion. It vanishes.
It's worse than vanishing. You've actually created what the report calls correlated failure.
Yeah.
Across a portfolio of vendors.
Correlated failure.
Yeah. The moment that one single underlying node fails, your entire carefully selected portfolio of tools and platforms fails right along with it, because they all share the same hidden dependency.
So the real due diligence question now for anyone building or running modern systems isn't just who is my SaaS
Yeah,
provider.
that's not enough anymore.
It absolutely has to be who is my SaaS provider's infrastructure provider, and maybe even which region do they critically depend on. You have to understand the inherited risk flowing through your entire supply chain.
Precisely. You have to map it out. And the economic cost of getting this wrong, as we saw, was just staggering.
Let's talk about that cost. Direct revenue loss, obviously, for e-commerce sites that went down.
Huge productivity loss. Think of all the engineering teams just completely unable to deploy code, diagnose issues, or even log into their tools. Hours, days potentially, just lost.
Right, and reputational damage, too, especially for B2B SaaS companies where uptime is basically a core feature.
Absolutely. Plus, don't forget the Kinesis failure meant actual irrecoverable data loss in some cases for those time-sensitive pipelines. That's gone forever.
So, given all this,
Yeah.
this widespread economic earthquake, as the analysis called it, the market reaction, or rather the lack of reaction for Amazon stock, AMZN, was pretty interesting. It was surprisingly muted.
It was, wasn't it?
Doesn't the financial world care about a major systemic failure knocking out huge parts of the internet?
It's a really great question. And the analysis suggests that right now, at least, the market tends to view AWS almost like a utility, like the electric company.
Cool.
Single outages, even really big ones like this, are kind of considered an inherent risk. They're sort of priced in as a cost of doing business at that scale.
Because AWS is so dominant. Exactly.
Okay.
AWS has such a dominant market position, and frankly, the switching costs for customers to move entire workloads elsewhere are so incredibly high
Yeah.
that the market basically shrugs. It's like, okay, that was bad, but where else are most of these companies realistically going to go?
So the market effectively gives AWS a pass on the single event, despite the chaos. But you could bet the competition didn't give them a pass.
Oh, absolutely not.
Yeah.
You can be sure Microsoft, Azure, and Google Cloud Platform GCP immediately saw this as a huge opportunity.
Right. Narrative ammunition.
Massive ammunition. They leveraged this outage aggressively to push the multi-cloud narrative, to question very publicly the wisdom and soundness of AWS's core architectural choices, especially around SE1.
Okay, but let's be real for a second about this multi-cloud debate.
Yeah.
The analysis we looked at frames it, I think, quite wisely, not as some simple technical checkbox exercise, everyone must use two clouds.
No, it's much more nuanced than that.
It has to be framed as a rigorous economic decision.
Right.
It absolutely has to be. Because, true, effective multi-cloud isn't easy. It's highly complex to set up and manage. It's definitely expensive. You often pay premiums or lose volume discounts.
And the operational overhead.
Double the operational overhead, yeah. Different tools, different APIs, different expertise needed. And just imagine the nightmare of debugging a problem that spans two different cloud providers. Whose fault is it?
Yeah, finger-pointing galore.
So organizations really have to ask that critical question. What is our actual quantified cost of downtime per hour, per minute? And then how much are we rationally willing to invest in terms of complexity and cost to mitigate that specific risk?
It's about finding the right balance.
Exactly. Resilience isn't some moral imperative you chase at all costs. It's a feature, like performance or security. It has a cost, and it should have a measurable return on investment based on your specific business needs.
Okay, so distilling this down, the strategic takeaways here seem invaluable. For anyone building software or investing in tech today, we synthesized 4 core lessons, right? Pulled from the report.
Yeah, 4 key ones. First, you absolutely must explicitly account for the centrality of US East 1 in your own resilience planning. Doesn't matter where your main application runs. You need to understand that phantom dependency.
Okay, number 1, US East 1 awareness.
Second, accept that resilience is fundamentally an economic trade-off. Always do that clear cost-benefit analysis before you architect for, say, 5 nines of uptime versus 4. Is it worth the exponential cost?
Right, resilience is an economic choice. What's third?
Third, expect your competitors and cloud competitors like Azure and GCP to leverage events like this aggressively in their sales and marketing. Be prepared for those conversations.
Okay, and fourth, this one's maybe more for the investors.
Yeah, fourth is crucial for investors, but also for leaders planning long-term. You must monitor the trend of operational performance over time, not just react to single event headlines. One bad day is noise, a pattern is signal.
Trend over single event. Got it. Okay, let's make this really actionable now. Based on the analysis, what should architects, engineers, CTOs actually do right now? What are the concrete recommendations?
Okay, top of the list, absolutely number 1, audit your phantom dependencies.
Audit the phantoms?
Well, you
How?
need to actually map out your entire technology stack, not just your direct dependencies, but your indirect ones too. Demand transparency from your critical sauce partners. Ask them point blank, what AWS regions are critical to your services control plane?
So if my monitoring tool or my CI/CD pipeline or my identity provider relies heavily on us East 1.
You need to know that. You absolutely need to know. That's your true inherited risk exposure right there. You can't mitigate a risk you don't know you have.
Makes sense. What's the second recommendation?
The second is more of an architectural mandate, designed for authentication failure.
Okay, design for auth failure. What does that look like in practice?
Architects need to explicitly plan for the scenario where IAM, or whatever auth system you use, goes down or becomes unavailable. This means designing critical systems, especially recovery and monitoring systems, to maybe enter a gracefully degraded state.
Instead of just falling over completely?
Exactly. Perhaps they could rely on cached permissions for essential recovery operations, just long enough to get things stable, rather than feeling hard and immediately the moment the central auth service hiccups.
Okay, build in some local resilience for auth. And the third recommendation.
The third one loops right back to the economics we discussed. Treat availability as a feature.
Availability is a feature, meaning.
Meaning, calculate your quantified cost of downtime. Get specific. Is it $1,000 an hour?
Yeah.
$100,000 an hour? Know that number.
Okay.
Then perform that rigorous cost-benefit analysis. For many, many companies, investing in rapid recovery, being able to get back up and running in minutes or maybe an hour after an outage occurs, is a far more rational, economically sound choice
And what?
than investing potentially millions in incredibly complex, active multi-region, multi-cloud architectures that aim for absolute prevention of any downtime, which might be practically impossible anyway. Focus on mean time to recovery, MTTR, perhaps more than mean time, between failures, MTBF, for some components.
Got it. Optimize for recovery speed based on cost. That makes a lot of sense.
Yeah.
Looking back, this outage was maybe inevitable in a way. Operating systems at this kind of unprecedented complexity at hyperscale, things are going to break.
It seems so. It definitely forced a confrontation with a lot of assumptions we all held about how the cloud works or how it should work.
And it highlights that resilience isn't just AWS's problem to solve alone.
No, it's clearly a shared responsibility now. Cloud providers, yes, they need to be more transparent about these architectural trade-offs, about where these phantom dependencies lie. But customers, users, all of us, we need to become much more sophisticated consumers of risk. We can't just blindly trust the global label. We need to ask the hard questions and understand the answers.
So the immediate financial market, as we discussed, largely ignored this single outage, shrugged it off, priced it in. But what's the real long-term risk indicator? What should we actually be concerned about?
That's the final crucial point from the analysis. The true threat, the thing that should keep CTOs and investors up at night, isn't a single headline-grabbing failure, no matter how massive it feels on the day.
It's the trend.
It's the trend. If AWS, or frankly any of the hyperscalers, begins to show a sustained, measurable increase over time, an increase in the frequency of outages, or their duration, or the blast radius of these kinds of systemic failures.
Okay.
That trend, not the noise and chaos of a single bad day, that's the real signal. That's what could indicate systemic decay, a loss of operational excellence, and that would justify a massive reevaluation of the whole investment thesis in that provider.
So the provocative thought for you, the listener, is maybe to start monitoring that trend yourself. Look beyond the single headline.
Exactly. Track the patterns.
Well, thank you for joining us for this deep dive into the architecture of systemic risk and the lessons from the US East 1 outage.
Thanks for having me. Fascinating, if sobering, stuff.